Hello everyone, in this video we're going to learn about the breadth first traversal of a binary search tree. I have talked about the depth first, the recursive depth first traversal of a binary search tree in my other videos. Make sure to also watch that one. But here we're going to see that was the breadth first traversal of a binary search tree. So here's an example that also I use in my other video for the depth first. We have a binary search tree. As you may remember, the binary search tree is a special case of a tree in which each node has at most 2 children, so either 0 or 1 or 2 children, and then each node has higher value compared to its left child and the left side child subtree, and also smaller value compared to right side of the tree, or from its right side. And here we're assuming that the items are unique, so each parent again, or each node has a different value. For the sake of simplicity, like many other videos that I have posted, we're assuming that the data of like each node is numeric, or another it's going to be very easy to convert actually any key or any like that to a numeric one. So here again, we're assuming that these numbers are representing the keys associated with each node that we have in the tree, even this is not might be the actual data. So with this explanation, let's go to the algorithm of, or the implementation of the breadth first traversal of a binary search. One thing that we need to use here is a queue, and queue is another data structure. Again, you can watch my other videos about queues as well. I have explained the in-queue method and also dequeue method. The in-queue method is the method that pushes an item or at the very end of the queue, and the dequeue method is removing one item from the very front of the queue. So queue is the first in, first out, means the very first thing that will be inserted or pushed on back of the queue will be the very first thing it will be that gonna be inserted. Okay, so the first in, first out, unlike the stacks, that is last in, first out, which is the last one inserted, gonna be the first thing to be removed. Okay, we need this explanation and this like introduction in case that any of you are not familiar with the like this concept. So here we're using a generic code, so we're assuming that the data of like each node is from the type E, and we also have defined already the queue. So the breadth first start with creating an empty queue, and it also will start to in-queue the root node to the queue. So the very first node that are gonna be pushed or in queue to the queue will be the root. So let's see that how the breadth first search works in general. So the breadth first start from the top to the bottom and from the left to the right. So that's how we're going to work. We're going to print or visit every node of the tree using the breadth first. So we're going to visit 10 first, and then going to the left, and that means going also to the bottom or the more deeper part of the tree, and then we're going to the right, and then we're going back to the left and also going one level down. Then we're going to visit the whole level, and then going to go back this like the next level, and then going to visit every other node that we see. So that's the way that the breadth first traversal of the tree works. So let's see that how using the queue we can actually implement that method. So as I said, we're in-queuing the very first node, which is the root, in this case 10 in this queue. So I'm going to write with this example, with the example I have here, the steps in order to show the way that the breadth first method works. So we're going to start with in-queuing, and I'm going to use just enqueue for just for short, and we're going to queue 10, which is the root of the tree. And as you see here, we have a while loop here that says while. So this everything here will be done inside the loop. While the queue is not empty, means that there's still some nodes to visit. We're going to dequeue the node from the from the queue. So we're going to dequeue, and the dequeue will give us 10. And as you see here, we're going to visit the current node. It will be the node that has been removed from the queue. So we're going to visit 10, and then I'm going to just write the numbers in the order that they are printed here on this part of the board. So after we're done, we need to go and visit the left side of the, or we're going to visit the or add the children of that node to the queue. So what we're going to do, because it is the bottom, top, bottom, and the left, right, we're going to in-queue the left child first, and then we're going to in-queue the right child. So we're going to in-queue the left child of 10, which is 5, and then we're going to in-queue the so let me just be more like I provide more details here. So I'm going to in-queue 10.left, which is 5, and in-queue 10.right, which is again here is 20. So, and again, because a queue is a first in first out, that means that 5 will be visited before 20, and that's exactly what we want to do. So after that, we're going back to the the very beginning of the while loop. We're check because the loop is not the queue is not empty, and we have the number 5. So I'm also going to draw the queue, as we are also having this one here. So let me draw a queue. So at first we had number 10, and then we dequeued number 10, so it's like we're just removing that, and then also we in-queued 5, and then we had in-queued 20. So just to keep things simple, I'm going to just say that. So we also dequeued 5, like the 10 here. So instead of like just putting that sign, I'm just removing that from the queue. So we have 5 and 20 in the front of the queue. 5 is the very first one. Now that we visit 10, and here's the 10, so again we're going to check if the queue is not empty, which is not, and then we're going to dequeue from the 3. So we are in the second one, so dequeue, and it's going to be 5, and again that means that 5 will go away for now. Again, before I'm just going to put this, that means that 5 is gone, but at the end I will just erase the number 5. So we dequeued 5, and it's going to want to visit number 5, so 5 will be printed. So 10, 5, and as you see here in the tree, we came here from the top to the bottom and from to the left. And now next one is we're gonna in-queue its left child and right child if they are not null, which are not null. The left child of 5 is 3, and the right child of 5 is 8. So here I'm going to in-queue 5 that left, which is 3, and also I'm going to in-queue 5 that right, which is 8. So here 3 and 8 have been added to the end of the queue, and again, as I said, now I can just erase number 5 again, just to keep things simple. But again, at the very beginning, that's the same thing for showing the dequeue process. Now that we have printed 10 and 5, again, I'm just maybe just put the check mark here, so 10 and 5 are printed. Now it's very easy to see that the next number going to be printed and is in the front of the queue is 20, and exactly that's how the breadth first traversal works. So going to the next iteration of the loop, we are going to have the dequeue, which going to give us number 20, and again we're going to visit number 20, so number 20 will go here. Again, just let's mark this one that it is dequeued, so it is dequeued, and now we're going to insert or in-queue the left and right child of 20, which are 15 and 25. So in-queue 20 that left, which I think was 15, just make sure it is 15, and then in-queue the right child of 20, which is 25. So here again, instead of writing the actual node dot write, I'm just using the numbers just to again, just for the sake of simplicity and for the purpose of like showing that how it works. So now we have 15 and 25 added to the end of the queue, so 25. And again, I can just erase 20 from the very beginning, just to keep the my queue simple. So 3, 8, 15, and 25. And as you look at the queue now here, these are actually the very third level of the tree. So, or the 3 from the left to right, then 8, then 15, and 25. And again, because it's a queue, so we're going to exactly extract or dequeue all of these items from the very the front of the queue to the very like the end of the queue. So it's going to be exactly based on the tree from very left to the very right of this like the level that we have. So after that, we're going to go to the next iteration. So maybe also it's good just to actually have these iterations here. So this is our iteration. So going to the next iteration, here we have dequeue what is on in front of the queue, which is again is number 3. And now we're gonna enqueue the left and right child of the like the 3. But here, as you see, 3 doesn't have a left child. So going back to the code, here as we see, if the current left is not equal to null, which is in the case is null, so it means that we're going to skip that one and go to the current.right, which exists, which is 3 dot is the node number 4 or the node with the value 4. So enqueue, and then it's going to be 3.right, which again is number 4. So number 4 will be added to the end of the queue, and again we just need to dequeue number 3, and also we need to show it here. So after 10, 5, and 20, the next node going to be visited is going to be the node 3. So here, as you see, the next number we're going to be 8. So again, just let me just also erase it here. So number 8 will be, and again that was one iteration. So here we're going to dequeue that will go as 8, and so 8 will be printed. It's going to be printed, and here 8 has only a left child and not the right child. So let me just again put this mark here, and then we're going to enqueue 8.left, which is 7. So that's again another iteration that we have, and we're enqueuing the left child of 8, which is 7. So if you look at the queue now and look at this number 4, you're seeing that we're actually are pushing or enqueuing the from the very left to the right of the next level of the tree into the queue. So 4, 7, and we we're sure that the next numbers to be pushed will be 18 and 20. So now we're done with 8. Again, just I'm gonna just say that you're done, and now the next number is 15, exactly what you expect after 8 to be printed. So we're gonna dequeue, and it's gonna give us 15. Again, just make sure that I'm not making mistakes. It's 15, and it has only a right child, which is 18. So we're gonna enqueue the 15.right, which is 18, and again it is another iteration that we have here. So number 18 will be pushed here, so I'm going to just write 15 here. So the next iteration is 25. So again, just like be faster here. So 25 will be dequeued. So again, that's a new iteration. So it's going to be 25. Make sure I'm not making a mistake. Yeah, it's 25, and it has only left child, which is 20. So it is 25 the left, which is again 20, and again that's another iteration. So let's enqueue 20 here, and so now we're done with also 25. So 25 will go away. So will go away, and then what we have going to be the next level of the tree, which is a start here and is 4, and as you see here it goes up to the very end of the queue, the very last level up. So again, I'm just going to be real fast because I think that's enough just to show all the details. So we're going to DQ, it's going to be 4, and because 4 doesn't have any left child or the right child, we're not going to add anything to the end of the queue. So we're just going to DQ 4. The next one is 7, so we're going to DQ 7. Okay, so that's itself is a one iteration. The other iterations that we have here, so we're going to be DQ will give us 7. So 7 also will be printed here, and then here again let me also show it in the queue, that will just go away. And then the next one is 18 and 20, so DQ 18. Again, 18 does not have a child, and then at the end we're going to DQ the very last one, which is 20. So 18 and 20 also will be added here, so 18 and 20, and again they are DQ'd one by one, and because none of them has any children, the queue will be empty. That means that inside this while loop the condition will be wrong, so queue is empty, and now we're done with the breadth first traversal of the tree. So if you look at again the output that we have here, so we had 10, we have again 10, then 5 and 20. So that's exactly how we see here. This is the very first level of the tree, and then is the second one, and these 4 are the 3, 8, 15 and 25. I think I made a mistake, I forgot to write 25 here, so 25. So let me write it better. Okay, so here is 25 and here is 4, and here is again the next level of the tree in these 4 numbers, and then here we have these 4 numbers for the next level of the tree. So 10, 5 and 20, third row or the third level, and also the fourth level of the tree. So that's an example of the the breadth first traversal and the implementation, and also its Java code of how it can be implemented using another data structure, which is a queue.